This lesson talks about the law of conservation of matter, or conservation of mass. It simply means that matter can't be created or destroyed. You can only change its form. So the mass of the starting substances, which we call reactants, has to be equal to the mass of the ending substances, which we call products. Now, just so you are clear, it does not matter in which order you write the reactants and products. So this is still the same thing as this. It doesn't matter which one of these comes first. There's a sodium atom, and here is a chlorine diatomic molecule. So when we put these two things together, we're going to end up with sodium chloride, and we know that that's just one of each because sodium is +1, chlorine's -1, that equals 0, so this is sodium chloride. But what do you notice? We've got 2 chlorines on the left and only 1 on the right, and the sodiums are okay. Let's take our chemical inventory. Okay, so I usually write whatever's in the equation right under the arrow, and then here I will say on the left there's 1 sodium, and on the right there's 1 sodium. So on either side of the arrow, this is where I'm keeping track of what I have. On the right here we have 1 chlorine, and on the left here we have 2. Though this formula is balanced, now we are talking about balancing the entire equation to make sure that what you begin with is what you end with, and that's not the case right here. It's not possible to just say, oh, there's another chlorine. Instead of just adding a 2 here to balance this out, we know we can't do that because we already just said that this is +1, that's -1, and so we can never just change subscripts. So to balance an equation, we're going to do that out front with what we call coefficients. And so essentially what this is going to mean is if we have another chlorine over here, what do we also need? Well, we're going to have another sodium. And so now I'm going to take inventory once again. So first I added a chlorine, and then I said, well, wait a minute, if there's a chlorine there, then it's going to probably need another sodium. So I'm going to add another sodium there. And so now we have 2 of those, but over here we only have 1. And so likewise, I am going to need 2 of those there. So now we are balanced. And so we're going to say that 2 sodiums and 1 chloride molecule is going to give us 2 NaCl. So our final balanced equation is going to have to look just like this. And so we've made 2 of these, and so we would put a 2 there. What this means is there are 2 sodiums and 2 chlorines, and then here we have 2 sodiums and 1 chlorine. Just like in formulas, we don't add the 1 in. Okay, here's another one. We've got silver chloride plus copper, giving us copper chloride and silver. And this is the one that you guys have done in the lab, where you had the little, squiggle of copper coil, and then what you found later was it actually got kind of silver coated on it. So I've listed every element we have here. And so on this side, we have a 1, and this side we have 1 silver. On this side, we have a chlorine, and on this side, we have 2 chlorines. And here we have a copper, and here we have a copper. It's pretty easy to see that this one has to start out with balancing the chlorine. So we can't have 2 on one side and 1 on the other. We're going to have to make 2 of these, and by doing that, again, we cannot put a subscript in there. We have to do that out front with a coefficient. So now this coefficient goes to the silver as well as the chloride. So we made 2 chlorines here, but now we also have to change this to 2. What does that mean? Well, now we have 2 over here and only 1 there, so must be we're going to need to put a 2 there. So when these numbers match on both sides of the element, then that means the equation is balanced. And so we would have two silver chlorides reacting. Okay, so we would have two silver chlorides reacting with a copper, and we would be getting copper chloride and two silvers, so that we have two of those, two, and one of those. Okay, here's another one. Got two ionic compounds. We'll learn what kind of reaction this is soon, but this is lead 2 nitrate, potassium iodide, giving us lead iodide and potassium nitrate. So in this case, the nitrate is the yellow, and I am just going to use that instead of breaking it down to make an N and an O3 right now. And the reason I can do that is because it's nitrate on this side and it's nitrate on this side. Let's do it this way first. So we have one lead on this side, and this 2 only goes to what's in parentheses. So that's 2 nitrates. And then we have 1 potassium and 1 iodine. Over here, we've got 1 lead, and here we've got 2 iodines, and here we've got 1 potassium and 1 nitrate. And so now you have a situation where you have this inventory, and you can see these are okay, but then these 2 aren't, okay? And so what I'm gonna do is go in and just start at, I don't know, iodine, just because I'm at the bottom here. And so if we have 2 on this side, we're gonna need 2 on this side. And so I'm gonna cross that out and put a 2, and then make sure that 2 is up there. Or I could have just put the 2 up there, but then I have to make sure you update it down here. Remember, the 2 goes to the iodine, but it also means that. So we've just made another potassium iodide. So now we have 2 of those also. So now we can go to the potassium, or we can go to the nitrate. As I'm working my way from the bottom up, let's just do the potassium next. So I now have 2 potassiums, but what did that also do? It just gave us 2 the nitrate entirely, okay? And so we've got 2 nitrates, and look what that did. It actually balanced this before we even got to nitrate next. So we have lead, nitrate, potassium, and iodine. All right, here we go again. So now I've just said that nitrate is yellow and oxygen is green. And so this represents a nitrate, an N and 3 O's. I've attached them to the lead there. And so again, our starting point won't be any different. Potassium and iodine, we still have 1 of each on the left. Lead, we still have 1 on the right, 2 iodines and 1 potassium, and now we have 1 nitrogen and 3 oxygens. Start the same way as I did before, kind of going from the bottom up. If we have 2 iodines here, we have to put a 2 over here. And so that changed this to a 2, but remember that also changes the K to a 2. So now we might as well go over here and make this 2 Ks. But then this is where we now have 2 of K, but we have 2, we're gonna have 2 nitrogens, and the 2 goes to this as well. Fine. All right, so we just made 2 N's, and we just made more oxygens, and so we have 6 of those. And so now it still balances, and I just wanted to show you that it doesn't matter as long as the nitrate, the nitrogen and oxygen appear as the polyatomic ion on both sides and not anywhere else, that you can actually keep it together or do it separately. It doesn't really matter. You'll come out with the same answer. There you go.